Hello, hi, I'm Vijay Babu Modiga. Now I'm going to present a classification model which is named mobile range price, mobile price range. Means they have given four classes as mobile price range. One is 0, 1, 2, 3. These are the four classes, multi-class problem. This is multi-class problem. Okay. Then now Uh, as usually, I have uploaded the file using from google.colab import files, then files.upload. From there, I have uploaded the file and then I imported the very common libraries. Those are pandas and numpy. After that, I am trying to read the file which I imported, pd.readcsv, and inside the circular brackets quotes, it is the name of the data sheet in CSV form. Then after that I have shown the first 5 rows and all the columns of the data sheet, that is by df.head. With the help of that I did that. And then df.shape, this is in order to show the rows and columns count. We have seen, if you see, 2000 rows, 21 columns we have. Then what are those columns? If you want to see, df dot columns, then battery power, blue, clock speed, dual sim, fc, 4g, int memory, like that all the columns came. Then next, unique values of the each column, that we can see here. I have done like df of battery power inside quotes and then dot unique circular brackets. It will give all the, it can have more values, but it will give only those values which are distinct in nature. Okay. And then df of quotes blue dot unique array of 0, 1, and a clock speed also, and clock speed also, the distinct values it will give, that we can see here. Next, dual sim, fc, like that for all the columns we can do. Then duplicate values, if you see duplicate values, there are no duplicate values in the data frame. If there are any, it will show as true, like that. But here it is not showing true because there are no duplicated values. That's why duplicated values sum is 0. Is there any null values to show that? df dot is null circular brackets is used. So here, just a minute. So here mostly there are no null values. If there are any null values, it will show true. Okay. Then is null count. This is the count of is null. And then I am plotting the variables, variable columns. Price range, battery power. It is shown here. And then price range, battery power, red color. Price range, px height. Like that we can do for all the columns also. So now I want to know the correlation of the given data frame. For that I have used df.corr circular brackets and then I am printing it. I am importing cpom library as SB. I want to know heat map plot. So that's why sb dot heat map of df dot correlation anode true. Then this will give the heat map plot. This is the heat map plot. The next pair plot. If you see the pair plot, G equal to SB. SB means C1. So SB dot pair plot of DF. So it will give me the diagram of pair plot. You can have for each and every variable. You can see. If you see battery power and then battery power, battery power to battery power. This is the diagram. This is the diagram. Battery power to blue. This is the diagram. Battery power to next column. Battery power to next column. Likewise, for all the variables, it is the pair plot. Next, I want to see describe what is the count value, what is the mean value, what is the standard deviation value, what is the minimum value, what is the maximum value, what is the 25, 50, 75 percentile value. Then for that, if you just write df dot describe circular brackets, it will show everything. For battery power, blue, clock speed, fuel sim, for all the columns, count value is there, mean value is there, standard deviation is there, minimum value is there, 25, 50, 75 percentile value is there, maximum value is there, like that. Then I am plotting the price range, a box plot. So this is the box plot. And then we know this is already the correlation matrix, correlation variable df dot correlation that is stored in CVR. Now heat map CVR are not true. Then we are giving the plot measurements here 10, 6. That is 10, 6. That is the 10 is the length and 6 is the width, like that. And then that is the heat map plot. And then from sklearn model selection I am importing train test split. And then if I see df.shape 2000 rows, 21 columns are there. X train, X test, Y train, Y test equal to train test split of X comma Y. What is X? Df dot ilog 0 to 1 all the rows and 0 to 20 columns. And then df dot ilog all the rows -1, that is last column. Test size equal to 0.25. 0.75 of the values goes for uh, train and train. 0.25 values goes for test out of the total values. And I am printing X train. Is the X train. and then this is the X test, X test, and this is the Y train, this is the Y test. And then from sklearn linear model I am inputting the linear regression. Model equal to linear regression, circular brackets, model dot fit of X train, Y train. I am fitting the model. First of all, from the given data. What is the given data? Given data is train value. We are training this model first. Then I want to predict with the help of X test. Model dot predict X test. Now the model is ready. We have trained the model. Now the model is ready to predict the values from the given X values. For the given X values, what are the Y values? That is what linear regression model is doing here. And then I have seen Y spread shape is 500 rows and one column. Y test shape is also 500 rows, one column. From sklearn preprocessing label encoder, L equal to label encoder, I am fitting the Y pred to label encoder. LE dot fit Y pred, because that is not in label encoder type. Y test is always in the required form, but Y prediction is not in the required form. That's why we are fitting Y pred form to label encoder, and then Y prediction. See, Y prediction equal to LE dot transform Y prediction. We are transforming Y prediction into a label encoder model type, because Y test is also in the form of label encoder type data. So that's why Y prediction also has to be converted into the same values. So that's why we did that, and then we have printed the Y test value. From sklearn matrix input accuracy score to see how much is the accuracy out of 100%. If you see 27.4% is only coming only with linear regression. If you go random forest classifier here, from sklearn.ensemble import random forest classifier, from sklearn.model selection import grid search CV, from sklearn import matrix, import warnings dot filter warning of ignore. You see random forest classifier, I am initializing random forest classifier. Forest parameters are these, and the classifier equal to CLF equal to grid search CV random forest classifier. Forest parameters given above, CV equal to scoring accuracy. And if you see here, I am training the model X train, Y train. We have given to the classifying model. We are training that model here. The estimator is random forest classifier in grid search CV. If you see Y prediction, CLF dot Y predict X test. For X values, we are seeing the output Y values. So then after that, accuracy score of Y pred and Y test. If you see 92.8% came. So a random forest classifier is giving the best results. Random forest classifier is giving 92.8% out of 100%. Means we have matched the output values 92% from the given X test values. Okay, thank you.